The last transformation that we're going to work with, and it's called a dilation. And so this is the example. Michael is using a photo editing program to adjust the size of photos for the yearbook. To avoid like stretching the image, he pulls a corner of the photo along a line, which is here, to stretch it out. Okay, so we're looking for a transformation that now changes the size of the figure because we started with this shape and then we blew it up to this shape. Okay, now all the other transformations that we've worked with so far have not dealt with changing the shape. Translating, rotating, and reflecting, we've talked at length about how the shape and the size stay the same, it's just the position. But now when we talk about this image, it's going to change the size. So how long is this? 2. Good. And how long is this? 3. Okay, so now how long is the new length? 4. And how long is this new length? 6. Okay, so you can probably already see a relationship between the original and the new. What do you notice?
1 by 2.
Yeah, it just got doubled. I doubled this coordinate, or this length by 2, and I doubled this length by 2. Okay. Oh, we already did that. Oh, actually, no, let's go back here. So let's talk about the coordinate. Okay. Let's look at this one. What's the coordinate of that B point? 2, 3. And its new coordinate is this D point. What's the relationship there?
4.
Good. So again, that same relationship that you identified with the lengths has to come, it comes back into play when we talk about the coordinates. Let's skip to this. So think about an image. This is my dog. This is Hercules. So think about resizing an image. Why is it important for me to not just drag it from the side, but to actually like stretch it out?
Like from the corner?
Like, why is this bad, but like this isn't? What's happening to his face? If this is my original, right? There's that handsome little devil. Why is this a problem?
Because you're just making his head wide.
Yeah, I'm like stretching it out, and the picture doesn't actually keep its format. But if I took my original, and the board's not really cooperating too much. All right, let me move that. So if I take here and I just drag, notice that everything stays the same. His cute little face is just getting bigger. It's not stretching. It's not being deformed. It's just blowing, almost like a picture. Imagine like a little picture that you took on your Instagram. If you wanted to print it out, you wanted to blow it up. You don't just like drag one side. You actually increase the entire size so that it still remains in proportion. So this is called a dilation. Anything you see in red, you're going to write down. A dilation is a transformation in which the original figure and the image are similar. What does it mean to be similar? Not congruent or identical, but similar. What do we know about similar figures?
They're the same shape, but different size.
So different size, but the relationship between the sides is the same. So if that first picture was like 2 units by 3 units, something similar would have been 4 units by 6 units because I could just double by 2. So in a dilation, the ratio of the length of a side on the original figure to the length of the corresponding side on the new figure is called the scale factor. We're going to go over what that means. And also add to your notes, the center of the dilation is the point that is transformed to itself by the dilation. We'll go through all of these. So for the image that we saw on the previous slide, not the dog, the actual textbook image, the scale factor here would have been a 2. And the reason that the scale factor is a 2, I actually doubled every length. I doubled the length of 2 to go to 4. I doubled the length of 3 to go to 6. Okay, if I had a scale factor of 3, I would have went from 2 to 6. Because I would have multiplied it by 3. So the scale factor is really what you're going to do to the shape. Now, if I had a scale factor of 2 or 3, I'm making it bigger. What do you think happens if I have a scale factor of like 1/2? what's going to happen to this shape? What happens if I multiply something by half?
It's gonna get.
Oh, it's gonna get smaller.
It's going to get smaller. Yeah, so while multiplying by a number greater than 1, it's going to make it bigger. If I multiply by a fraction, it would shrink it. You'll see some examples in the next couple of days. So when you're asked to do a dilation, they're going to give you the scale factor. They might say, here's this shape, make it bigger by a scale factor of 3. Or they would show you an original shape and a new shape and ask you, what is the scale factor? So that term will be used quite often. The center of dilation is like where the dilation started. So in the little sketch that I have here, the center of dilation would have been the origin because on the original image, its coordinate was 0, 0. But on the new bigger image, its coordinate was still 0, 0. So it was still the same. It ended up being the same. Okay. Does everyone have this written or are we still working on it? Okay, no problem. I know it's a little bit longer. Are we good to slide? I'm still writing. I'm not sure if you're writing. We will still talk about all these terms, so if you don't get the exact definition, you'll have something to write as we move forward. So the scale factor here, like I just mentioned, of this image is 2 because the ratio of this length, this new length of 4 compared to the original length of 2, and the ratio of this new length of 6 and the original length of 3, the ratio there is 2. The center of dilation, that point that didn't change, was that point O. It was still in the same spot. So what would I get if I wanted to dilate this parallelogram with a dilation and a scale factor of 3? So if the center is here, let's identify the coordinates. This coordinate here is 2, 0. X is 2, y is 0. The coordinate here is X is 0, y is 1. This coordinate, X is -2, y is 0. And this coordinate, X is 0, y is -2. If I wanted to dilate this by a scale factor of 3, what should I do to every coordinate? Good. So, scale factor of 3 is going to be multiply every coordinate by 3. So that first coordinate of 2, 0, what would it become?
6, 0.
It would become, if I multiply by 3, 6, 0, which is over here. How about 0, 1? What would that become? 0, 3. Good. 0, 3, which is right here. How about -2, 0? Good. It would become -6, 0. Why are they still 0?
Because Because anything times 0 is
Because anything times 0 is still 0. Good. How about 0, negative 2? It would be 0, negative 6, which is down here. So if I wanted to create that shape again, oh wait, did I? Oh, 0, negative 6. Oh, I'm sorry. This coordinate was 0, negative 1. I accidentally wrote negative 2. So if it was negative 1, it would be negative 3. Sorry about that. So my shape now looks like this. What do you notice about the new shape and the old shape? It's bigger. Good. But what is still the same? So the size is different, but what's still the same?
The angles.
Yeah, the angles are still the same. So the angles are still congruent, but the entire figure isn't because it's not identical. So when you see these dilations happen, it's going to be the same image, just getting bigger or smaller. Okay, so let's do one more before we do some practice. Let's say we are going to dilate with a scale factor of 4. What are we going to do to every coordinate? Multiply by 4. Okay, what's this coordinate here?
1,
6,
1.
1. Good. How about this one?
6, 6.
How about this one?
4, 8. 4, 8. No,
2, 8.
2,
8. And this last one?
3.
3. 3. Okay. I want you to find all 4 coordinates if we're going to dilate with a scale factor of 4. So we will graph them together, but find the coordinates. All 4 coordinates that are there, we're going to dilate by a scale factor of 4. So write down all 4 coordinates. Mm-hmm. And don't worry as much about putting the image on the paper. Let's focus on the coordinate because once you have graph paper, that image is going to be a little bit easier to create. Right now, the actual calculation of dilation is what we want to work with. Does anyone want to share one of the new coordinates that they got? Christian, what do you got? Which one did you dilate? 2, 8. What did 2, 8 become? 8 and 32. So he multiplied both coordinates by 4. So he ended up with 8, 32. So I'm going to plot that where x is 8 and y is 32. I have to move this a little bit. 8, 32. Michael, give me one.
6, 6.
Good. 6, 6 is going to be what?
24,
24, 24, because I multiply both by 4. So 24, 24 is here. 2, 8. Who has another one? Which one? 3, 3 became 12, 12. That's all fine. That's 12, 12. Here. And how about 6, 1?
6, 1 became 24 and 4.
Good. 24 and 4. So where x is 24, y is 4. All right. So I'm going to connect these, but I'm going to erase all this stuff. So that you can see the image now. So this connects with this line. This connects here. This connects here. So
That's the same.
What do you notice about the shape?
It's same.
Yeah, it's still the exact same thing because what we did.
Miss Caravano?
Hi.
Excuse me, hon. May I have Helena Overton for a moment in the office?
Yes, you may. So that image, because we did the same thing to every coordinate, it's still going to be the exact same relationship. They're just going to be in different places. Alright, so we're actually not going to do this one. We're going to pause the video. I'm going to give you your activity.